My name is Adam Chandley, and this is my video presentation for the final project in data mining ISM6136. Today we will explore how I use the Portugal bank data marketing dataset. I used a special mining application, which is Microsoft SQL Server 2016 Analysis Services, and I combined that with Microsoft Visual Studio 2015. In this video, we will review the steps that I took to mine the data, as well as the two groups that I used as part of my PowerPoint presentation, as I called them Group C and Group D. Let's get started. Okay, so we're inside of Microsoft Visual Studio. This is the integrated development environment that we use to mine data, among other things, inside of Microsoft SQL Server. So over on the right-hand panel over here, you'll see that we have various mining structures that I've already predefined. You'll notice very specifically that I have the Group C and Group D data sets. So we'll go ahead and pull that open and we'll look at the structures I've developed. Under here, I've selected a few columns for each of my mining structures from the existing data set that I found interesting and worthy of mining for different purposes. In this case, I chose a variety of categorical attributes so that I could use all of the different mining models available to see if anything applies. So when I go over to mining models, that's actually Microsoft's language for the different types of algorithms that we can apply to the data. In this case, I've taken the liberty to apply all the available types so that we can get a wide look at both how SQL Server handles data mining, as well as just really see how the outcome can be applied. Just for the sake of demonstration for this video, if you want to create a new mining model, we'll just put in something junky there. We can see the different algorithms that are available. In this case, we've got association, clustering, we can do trees, we've got the two different types of regression, naive Bayes, and neural networks. So just for fun, we'll just pick a neural network here and apply it. And you can see that it automatically took my existing structure and applied a new neural network object to it. One row that you will see that doesn't exist in the data set is the customer ID. I made that up. With SQL Server Analysis Services, there has to be a primary key on your data set coming from the T-SQL table. So I simply created an identity column for each record so that they were serially inserted into the table. It doesn't actually perform any function, it's just how Microsoft ties things back. So we'll go ahead and drop that. So we're back where we started. We'll also take a look at the Group D just for clarity's sake. I used the same exact formatting. I've got all 5 different types of data mining algorithms present, and in this case I've got a bit more of a mix of different types of data. So let's go ahead and switch over to SQL Server Management Studio, and we can review the outcomes of these different mining models I've created. So okay, so here we go. We've got along the top I've got my final Group C and my final Group D, and underneath each one all the different models are provided, if you will. They're in alphabetical order. So we'll start with final Group C, and we'll jump to the top for our association rules. Okay, so we've got it pulled up here, and the first display you get under the Rules tab is a sorted list by probability and the scored importance that they've provided against the different rule sets that it's produced. Obviously, it's set up a little different from Weka or with SAS or even RapidMiner. They're all different in their own way, and Microsoft has certainly customized it, but you at least get some general idea of how it's applied rules with the data set that it's ran with. If we go to item sets, we can actually sort through all the different findings and how many different times that it found that finding, which I think is very telling if you use it correctly. There's also a filtering option here that can make things more interesting. So for example, if we want to only show items that are related to customers, what am I trying to say here, that actually partook in the bank marketing and accepted the offers, we could apply that, and now we can see that of the sampled data set, 3,640 did say yes, and then we start breaking it down for the different things that apply to yes, sorted by how many actual yeses we have to support that. And they're nested and all kinds of good stuff there. It's just very, very good visualization of the data. So we'll jump over to the next mining model, and we'll take a look at clustering. This cluster diagram, in my opinion, doesn't tell you a lot, so we'll go ahead and jump over to the profiles and characteristics. This, on the other hand, I would argue is a selling point. We've got very nice histograms for each of the different clusters and each of the different variables and attributes that apply. In the case of final group C, we're looking at how previous outcomes affected take of additional offers. And we also looked at see if any of the other categorical or binary, in this case, variables applied, like loans and housing. What we found is that both housing loans as well as personal loans have a very negative relationship with uptake in our marketing platform, but we've got a very nice histogram here that can really help determine where the positives and the negatives are. For example, we've got a cluster 4 here with a very high rate of uptake. In this case, 82% acceptance from that group. And if we look up through, we can see that they are mostly low mortgage having individuals that have never had previous marketing, etc. Again, it's all worth drilling down into. It's very interesting data and very interesting perspective. So if we go over to characteristics, it basically gives us the lessons learned from clustering and a nice probability chart with percentages that can help us justify that probability. It's great. So let's move over to decision trees for final group C. And I've got a legend in the way here. I apologize. See if we can jump that out of the way. Okay, so it's created a nice decision tree for us, and what it's done for us as well is colored in where the hottest path is, so to speak, to help us predict the outcomes. It's all very self-explanatory. In this case, what we're looking at is that folks that did not have a previous marketing attempt, or at least it was unknown to that person, we have fairly good presentation there. We can see how a mortgage or even a personal loan may or may not have affected their uptake of our product. In our case, we found that for the most part, it's a pretty solid line between no on all the uptake of related services within the banking institution. Not really found a use for this dependency network here, but I'll look forward to learning more about that at another time. So let's look at naive Bayes as well. So we'll jump over to attribute profiles, which looks a lot like clustering. Again, we've got histograms for the applied attributes. Naive Bayes does not work with the numeric attributes, so we're just looking at our binaries as well as our categoricals. And it still gives us a nice look at how things like defaults and the housing and loan uptake can affect previous outcomes. For the most part, we're looking for the purple here, people that said yes in the past, and they have less housing and certainly less loan uptake and virtually no defaults. Again, similar with the clustering, it gives us some characteristics of these attributes that can just help us see where the most likely attributes are to influence our modeling behavior. So let's jump to neural networks. And this one we only have one presentation, and I would argue that I'm not a big fan of this, and I would imagine that I need to do more learning and research. I'm a big proponent of SQL Server, but I'm not very familiar with the mining aspects of analysis services. I can walk you through the cubes and the mentions all day long, but this is new to me. But within here we've got favorable outcomes related to the variables or attributes presented. Great place to learn how various pieces of the data puzzle apply to the outcome we're trying to derive. So that's it for my presentation today. Again, I used a Microsoft SQL Server 2016. I'd imagine there could be some abnormalities in my data, as this is a pre-production release of SQL Server, but I encourage all to use this product for this purpose. I've learned a lot just as part of this project, and it's been not only, again, a learning experience, but very, very interesting, and I like the way Microsoft's put it together. Unlike the WECAs and the SAS, once you use Visual Studio to build a mining structure and a series of models, unless your data changes and unless you actually process your group again, the data is stored after the model's been built. So I can close out of this and reopen it. I can reboot my system or my server, however you want to approach it, and we don't lose our results, so we don't spend anywhere near as much time reprocessing data. And also, where it's a mature platform that is very widely used, it's the #1 database product in the world, it's very, very fast. For example, if I want to go to my project data and I issue a deploy, I could do yes. It's going to deploy my packages, so I've sent my code to the server, and if I want to go to the server now, I can actually hit process on an entire group of mining models, and if my data changed for some reason, or if I changed my process, it's going to completely refresh all my models. And you'll notice here that it's very fast compared to Weka or even the SaaS product in the cloud. Now I'm sure if you had a localized SaaS product, probably a lot faster, but this got done in less than 30 seconds. Looks like here maybe 10, 11, yeah, here we go, 11 seconds, and it's processed 5 models already. It's excellent. So I'll stop shilling for SQL Server. I learned a lot from this project. Obviously the data set's not particularly important in my life, but I appreciated the complexity and the curiosity that it brought. I intend on creating a quick, maybe 7 or 8 minute video showing how other students can leverage analysis services in our MSDNAA, or even just the 180-day evaluation version that's available for Microsoft, to use this tool and get familiar with, again, a world-class product that just happens to have data mining built in as well. Thank you very much for watching my video. This is Adam Chandley. Bye now.